All right, welcome to the third video of data analysis. We are going to get started today by making a whole lot of visualizations. We're actually going to make more visualizations than you can possibly use, but ultimately that will be a good thing. It's always better to have more than too much than not enough. By the end of this tutorial, you will know how to make a scatter plot, a map, a pie chart, a bar chart, and a line chart, all in Tableau. We're going to make all of these visualizations with that restaurants data set that you've already cleaned. But before we get started, I would like you to watch a video on pill types. So go ahead and hold on, and I will cut it into here. You can also go out and watch the link on your own. This video is going to give you an overview of the different types of pills and what we mean when we talk about dimensions and measures and what the difference is between them.
Welcome to this video on understanding pill types. You can download the exercise workbook to follow along in your own copy of Tableau. When we bring a field to the view from the data pane, Tableau creates a pill. Whether or not that pill is a dimension or a measure, or continuous or discrete, impacts every level of functionality in the analysis, from the way the data displays to the deeply technical, behind-the-scenes approach to how data is processed. Knowing the features of how Tableau works with pills is vital to staying in control of the analysis. Measures are usually metrics or numerical data, like shipping cost. Inside of Tableau, measures are aggregations. They're aggregated up to the granularity set by the dimensions in the view. The value of a measure therefore depends on the context of dimensions. For example, the result for the sum of shipping cost is dependent on if we mean overall, just under 1.5 million, or per order priority level, from 65 to about 550,000. Dimensions are usually categorical fields, such as order priority and region. Specifically in Tableau, dimensions set the granularity or the level of detail in the view. We typically want to group our data by some combination of categories. What dimensions we use to build the view will determine how many marks we have. Here we have 4 order priorities, critical to low, and we have 4 marks. We also need to consider if the pill is continuous or discrete. Continuous numbers can take on any value in a range. Discrete numbers have distinct, separate values. Most of the time, dimensions are discrete and measures are continuous. However, this isn't always true. It's possible to have numeric dimensions be continuous or to convert a measure to discrete. For example, discount is currently down here as a continuous measure. We may want to change it to discrete by right-clicking and selecting Convert to Discrete. When we hover over the pill, it's now blue, and the icon is blue as well. We can also convert it to a dimension simply by dragging it into the Dimensions area of the data pane. Note that these two operations, converting to discrete and converting to a dimension, are not synonymous. For the rest of this video, we'll mostly be talking about continuous and discrete data instead of measures and dimensions. If you're ever in doubt, remember, dimensions come out into the view as themselves, measures come out into the view as aggregates. Discrete pills are blue, and continuous pills are green. Let's start with axes and labels. When a continuous pill is brought into the view, it creates an axis. This will automatically fill the entire view along that direction. When a discrete pill is brought into the view, it creates a label with panes for each value. This will take up as much or as little room as required. Whether a pill is continuous or discrete also has an impact on default behavior for colors. A continuous pill on the color shelf will create a gradient. A discrete pill on the color shelf will create a color palette, where each unique value is assigned a color. Here I'd made a copy of my sales field and changed it to discrete, but the underlying data is identical. On a map, The default behavior depends on whether the pill is continuous or discrete, but also if it's a dimension or a measure. If the geographic type allows it, a measure on color defaults to a filled map. A dimension on color defaults to a simple map. Whether the colors are gradients or palettes depend on if the pill is continuous or discrete. Dates can be brought into the view as either continuous or discrete. If the date icon is blue in the data pane, then the default when we bring out that pill will be discrete. But if we right-click drag, we can select specifically what sort of date we want. We can change this property in the pills menu. The options at the top are discrete date parts. The lower section are continuous date truncations. Continuous date truncations are treated as an ongoing progression along an axis. Here, there's a single trend line, and December 2012 leads into January 2013. Discrete date parts are treated like categories. Each year is a different category, and there's a trend line here per year. There is a break between December of 2012 and January of 2013 because month and year are simply labels. Filtering on a discrete pill, such as category, brings up options related to the specific list of values for that pill. Filtering on a continuous measure, such as profit, first asks if we want to filter at the row level or aggregate level, then brings up options for continuous ranges. Thank you for watching this video on understanding pill types. I hope this helps explain some of why Tableau behaves the way it does. We invite you to continue with the free training videos to learn more about using Tableau.
All right, welcome back. You've definitely learned a lot about the difference between dimensions and measures. And we're going to get started by asking about the relationship between food rating, service, ambiance, and Yelp rating. We want to see if one predicts the other. Our constant across all three of those, the one that we're going to compare to, is going to be the food rating. So we are going to start by selecting a new worksheet if you haven't already done so. So you should have sheet 1. If you were over here in data source, that's fine. But you want to make sure that you have selected sheet 1 by the time that we're making the visualization. As you see, I just opened my Tableau and it is authenticating in my browser in order to reload that Google Sheets data. And you see here that it's re-authenticated. All right, so I'm going to go back to my sheet 1. And the first thing that I'm going to do to get started is I'm going to drag my restaurant dimension over here to my marks card. What that's going to do is to make sure that the granularity of our visualization is at the restaurant level rather than summed or otherwise aggregated in some way, as I discussed in the video. And we're going to start out by dragging the food rating into the rows, and this gives us the not terribly much information. It gives us the food rating for each of these restaurants and nothing else. We're then going to drag the ambiance rating into the columns, as well as the service rating and the Yelp star rating. All right, and what you see here is a set of small multiples, each of which is a scatter plot. And Tableau is excellent, really truly outstanding at doing small multiples. It's almost set up for it in this really magical way. And what we see from this data set is almost all of the restaurants have a 3-star rating, or a 5-star rating. So here we have everything except for Pegasus has a 5-star. We see the same thing here, and we see that the Yelp stars are even more clustered than, say, the service, which is really spread out here. So each of these is against the foods. We can see the relationship between the food rating and the ambiance rating. We are going to give this a new title. All I did here was I double-clicked on sheet 1. And by double-clicking, I get this dialog box. and that allows me to fill in a title here. So I'm going to call my visualization food rating by ambiance, service, and Yelp ratings. Okay, not a terribly creative title, but it works. Click apply and OK, and it should appear here without too much problem. One thing that could make our visualization here better is if we had a tooltip. We had all of that rich detail in our data set, and we don't necessarily want to lose it. So I'm going to take these details, and I'm going to drag it over here onto the tooltip category. And when I do that, what I see is I get this the details here in the tooltip about each point. But the way it is right now isn't terribly attractive. So I'm going to go ahead and click on Tooltip here. I'm going to open this dialog box, and this allows me to customize my tooltip for each data point in my visualization. So I'm going to get rid of the title restaurant, and I'm just going to have it be restaurant, because we should be able to assume from the data that it's a restaurant. I'm going to make this a little bit bigger. And down here, rather than saying details, I'm going to call it a review, just to make it sound a little bit nicer, honestly. And I'll keep that the same size, but I do want to make my review bold-faced. So I'll go ahead and click on bold. This is a pretty basic text editor. You can do underlining, you can change the font a little bit, you can change the color. That's about it. So, you're a little bit limited. You can, however, put in a URL. And as we'll see later on in the semester, you can kind of hack that in a really interesting way in order to get your tooltips to display images, which can sometimes be really useful. Anyhow, but that's for later in the semester. Right now, I'm going to get rid of the food rating and the ambiance rating because it doesn't really make sense, because at this point it's redundant. Those numbers are really easy to read on this chart. We're dealing with numbers less than 5. It's easy to see them and distinguish one point from another. So I don't need to include those in my tooltip. Now, if these were really packed together, or if the numbers were a little bit harder to read, you might want to keep those numbers in your tooltip there. All right, so I'll click OK, and when I come here, what I find is I have the name of the restaurant pops up, and then this review down here. Okay? But it didn't apply to all of them. And that's because we actually haven't added the detail to all of our visualizations. So I'm going to have to do it for each and every one. So I have my details here, and if I click on the tooltips, I can have the exact same formatting here. Go ahead and get rid of the restaurant header, make it a little bit bigger, and I don't want the food rating. I've made a bit of a mistake here, but that's actually kind of fantastic because maybe you did too. I'm going to call this review. That's not what's here. So I'm going to get rid of this because that's not what I want to have. And then I'm going to insert one of my data sources. And I'm going to insert my details. The most recently used variables will be down here. So I'll insert my details, click OK, and I get the same details here. Do it one more time over here, drag details down to the marks card, click on the tooltip, remove the Yelp star rating, remove the food rating, remove the word restaurant, change details to review, change the formatting a little bit, make this size 14. All right, and we have completed our first visualization. Congratulations on making a scatterplot. Now I'm going to have you go ahead and take a few minutes and make another scatterplot, somehow rearranging these variables. You can either use these 4 variables if you wish, or you can pick something else to show on a scatter plot. Remember, for a scatter plot, you probably want to use variables that are discrete rather than continuous. So you probably don't want to use time or anything like that. You probably want to use the ratings or something along those lines. All right, so go ahead and enjoy and take a few minutes and make your own scatter plot with the variables here. All right, welcome back. So we're going to take this opportunity to save our project. Tableau, like many heavy programs such as Excel and other heavy software programs, has a real tendency to crash, and you don't want that to happen to you. So make sure that you save early and often. All right, so it is about to get really confusing. So I want to change the name of my sheet, and I want to call it something else. I'm going to rename Sheet 1 to Scatterplot. This is going to help me later on when I go to build a dashboard. All right, so we're going to make another worksheet. We want to add a second visualization to our dashboard, and in order to do that, we're going to need another worksheet. All right, so now we are going to get started with making a map. But before we dive into making our own map, we're going to go out and watch another video. And this video will kind of get us situated and get us grounded. It goes into a little bit more detail than you actually need for this tutorial, so go ahead and enjoy. We'll be right back.
Welcome to Getting Started with Mapping in Tableau. This video covers the various options for mapping and using background images in Tableau Desktop. At its core, geographical analysis comes down to plotting points. The map image provides the background, and coordinates are plotted on it. Latitude indicates how far up or down from the equator. Longitude indicates how far east or west from the prime meridian. Any point on a map can be represented with latitude and longitude coordinates. In Tableau, coordinates need to be in decimal format. Positive latitudes indicate the northern hemisphere. Positive longitudes indicate eastward from the prime meridian. In this way, every point on the globe has unique latitude and longitude coordinates. Incidentally, Tableau uses the same projection as Google Maps, which is Web Mercator. If your dataset has latitude and longitude fields, Tableau can automatically plot them on a map. On the other hand, if your data doesn't have latitude and longitude, but you have geographic place names, such as city, country, or province, Tableau will determine their coordinates and provide the fields latitude generated and longitude generated. If your data contains locations without latitude and longitude coordinates that Tableau cannot recognize, you can add to the database and enter your own custom geocoding, or simply blend in the geographic data. The videos, expanding Tableau's mapping capabilities, and custom geocoding go into more depth. Locations can be plotted on a map in 2 ways: as a point or mark to represent the entire area, or a polygon covering the area. Tableau has polygon data, or filled maps, for many geographic locations built in. It's also possible to provide your own polygon data to create custom polygon maps, such as this map of national parks in the UK. Check out the Polygon Maps video for more information, including creating custom territories on maps. If the default map tiles aren't what you need, maybe your analysis is of ocean currents, Tableau offers the option for connecting to Mapbox or a web map service. There's a video on each of these options. If you need to do something like plot the location of cavities on a dental chart, you can upload an image directly and assign it coordinates, as shown in the Background Images video. The options for geographic analysis in Tableau are extensive and powerful. There are many options for customization to make sure your analysis needs are met. We invite you to continue with the free training videos to learn more about using Tableau.
All right, welcome back. So, as you remember from when we did the join earlier, we actually have latitude and longitude in our data set. Latitude and longitude was helpfully, not helpfully, also generated from Tableau. Tableau really tries to be a geocoder, but it really fails at geocoding. So I will illustrate why Tableau is not the best geocoder. So if I double click on the Tableau generated latitude and longitude, it'll actually fill it in automatically for us. And we get this one big picture of the world. This is one tile that fills up the world. What this means, and the fact that there's no points on this map, is actually that Tableau has no idea where we are. We can see that if we remove one of these, and then we get this longitude here that has one null. And what this says is, okay, filter the data for the null values, and then we have absolutely nothing at all. So I'm going to undo that. I'm going to throw my longitude back here. And we're not going to worry about that too much because ultimately it's not going to help us. If we work instead with the latitude and longitude that we generated earlier, we're going to get better results. So go ahead and double click on your latitude and your longitude. And unfortunately, what we have here is the average latitude and longitude. What that gives us is a centroid. And this centroid is the average of the centroids of the 5 boroughs. That is not what we want at all. We want to tell Tableau, hey, don't perform calculations on something like latitude and longitude. That's not something that you should be performing calculations on. You should be taking them as what they are. So I'm going to actually change that from being a measure into being a dimension. And this is going to force it to no longer have any calculations performed on it. Okay, excellent. You should see now 5 points on your map, 1 for each centroid of the 5 boroughs. Awesome. But for right now, all that we have here is the latitude and longitude. We don't have any more details. So we don't have the restaurant, we don't have any of the ratings, anything along those lines. So what we would like to do is we'd like to know how many restaurants are in each one of our boroughs. Is Brooklyn the most recommended place to get good food? Is the Bronx? What about Queens? So we're going to need to perform some sort of calculation on our restaurant. But you might remember that restaurant is a dimension, and you actually can't perform calculations on dimensions. You can only perform calculations on measures. So we need to force our restaurant into being a measure. The way that we do that is we just drag it and drop it in the measures. And what we get is a count of the number of restaurants here. So rather than having each restaurant individually, we now have a sum of how many restaurants are in our data set. Okay. And then in order to visualize this, if we drag this over here on the marks card, what we see is that we get a count of the number of restaurants in each borough. And here we have 6 restaurants in Brooklyn. All right. I think we have 0 in all of the rest because at the time of recording, this is only data from me and my family. We live in Brooklyn. So this is great, but we're looking at centroids. And since we don't have latitude and longitude for the restaurants, we probably want to aggregate this at the borough level or the county level, rather than at some random centroid in the middle. So what we're going to do is we're going to drag our boroughs over to our marks card. But before we do that, we need to make sure that borough is serving the correct role. So I'm going to use borough name, or borough, however I misspelled that. And I'm going to change its geographic role. And I'm going to make sure that its geographic role says county. Yours might have defaulted to city. We're going to use this really useful thing about New York City, the fact that all of our boroughs are actually their own counties. Go ahead and click that. And then I'm going to drag my borough name over here to my marks card. And what I see is a polygon for each one of my boroughs. Excellent! I'm getting a little bit closer to what I'm expecting this to look like. Now, I would like to color my polygons based on how many restaurants are in each one. And this is actually really simple. So I want to know, I'm going to use color to encode something about the restaurants located within the boroughs. So I'm going to take my restaurants pill, I'm going to activate it, and I'm going to click on color. I'll drag it over to color, and what I see is a chloropleth map where each borough is colored according to how many restaurants are in this data set. And what we see is this is a data set all about Brooklyn at the time of recording. Hopefully yours has a little bit more diversity. So you are welcome to change your tooltip, play around with this a little bit. Maybe you want to see what the average or the total rating is for each neighborhood, in which case you could use the food rating and either do the median, the average, or the sum, depending on the question that you're asking. So the only thing I'm going to require is that we change the title here, and I'm going to say map of restaurant recommendations. And we know that it's a map, so I'm going to remove map of and just call it restaurant recommendations. I'll apply that, click OK, and congratulations! You've just made your first map in Tableau. All right, so we are going to go ahead and name our sheet map so that we remember what we are working with when we go to make our dashboard. And we're going to save our project. Now, before we move on, I will call out the elephant in the room, namely that this visualization is not terribly interesting. The boroughs aren't totally lined up very well. You know, there are some problems with this. For the most part, you're not usually visualizing things at the borough level, especially not counties. New York is quite unique in the fact that our counties are so very small. So I do recognize that, but we are still going to move on. Generally, when you work with this kind of data, you'll be working with much larger data sets. All right, so we're going to move on. We're going to make a new sheet, and this time we're going to make a pie chart. The question we're going to ask this time is who contributed the most responses and what was their average rating across the variables. We'll answer the second part with a bar chart. So for the first part, we're going to go here to the marks card, and we're going to start by selecting pie. And what we see is that this gives us a different option. Whereas previously there was nothing here, by selecting a pie chart, you get this other angle option. And we're going to have to use that in order to make our pie chart. And the reason that we're using a pie chart is that we want to show proportions of the whole. Whereas a bar chart is going to show us differences in values. So it's going to show us different heights, which is really great for showing like differences in raw values. Pie charts are okay for showing proportions of a whole. All right, so we're going to pull the first name variable onto the color chart. Okay? And we're going to pull the count of the restaurants onto the angle card. And what we get is a visualization of the number of contributions each person made. We have this null value here that isn't actually going to show up in our pie chart, but it is going to show up in our legend, and we don't want that. The reason that we have the null is because when we joined our data sets together, if not all 5 boroughs are represented in the data, then we have those empty rows that we really just needed in order to make our map, but now are kind of haunting us as we walk through each visualization. So I'm going to exclude those nulls just to make it a little bit tidier. Now, this is great, but it would be really nice if we could see the percent of the total for each one of these, or slices, I mean to say. The way that we're going to do that is we're going to click on the count of the restaurant, and we're going to do a quick table calculation. And our quick table calculation is going to be the percent of the total. And we want to make sure that we can see that. So we're going to click on Label on the Marks card, and we're going to select Show Mark Labels. There we go. All right. And then we're able to see how much each person contributed. And you're welcome to add tooltips to this or anything else that you would like. The only thing is that you do need to change the title. I'm going to call it Recommendation Contributors. I probably want to put restaurant in that, even though it's going to make it considerably longer. Without it, we don't have restaurant anywhere in our visualization, and that's not really going to work. All right, the last thing, and this is always something about pie charts, and I actually don't know why Tableau does this, but you see up here where it says standard, we want to go ahead and change that to say entire view. And that's how you get a pie chart that fills the entire space. I don't really know why Tableau doesn't fill it by default, but it doesn't, and that's fine. All right, congratulations. You successfully made a pie chart, and now we're going to move on to a bar chart to ask our the last part of that question. So now we want to know what each person's rating was. Wait, before we move on, don't forget the all-important step. Save your workbook, rename your sheet. Sorry, almost forgot. Pie chart. I'll just call it pie. All right, moving on now to sheet 4. So we are going to do a little bit of calculations. So we're going to create a new calculated field. The way that you do this is there's a drop down right here. So we're going to create calculated field, and what we want to know is what each person's average rating was. And I'm going to call this average rating, and it's going to be the sum of the ambiance rating. And if I start typing ambiance rating, it'll fill it in for me, plus the food rating, select that there, and the service rating. What this will tell us is if anyone is overly generous. So maybe one person uniformly rates all of their restaurants super low, and another person uniformly rates all of their restaurants super high. What this does is gives us a little bit more insight in normalizing our data and making sure that we're not just skewing based on the population that we're sampling. All right, so we're going to take our ambiance, our food, and our service rating, and we're going to divide it by 3, since they were all on the exact same 5-point scale. Okay. So I'm going to go ahead and click apply, and I have an error in my calculation because I have a typo. Hopefully you don't have a typo. We'll click apply, click OK, and then somewhere here we should have our average rating. Excellent. So we want to know by person what their average rating was. So we're going to drag the first name to the columns, and we're going to drag our new average rating to the rows. And what we see here is that these numbers are extremely large. What happened? Well, we were expecting averages, but what we got was a sum of the average. So people who contributed 2 have 2 of their average variables. So we see here that Devin and Michelle have twice the height of Candace and Janine. Way to fix this is to click on the sum, this little arrow here. We go down to our measure, and then rather than having the sum, we want to have the average. And this looks much more like it. This is what we were expecting. What we see is that Janine overall rates restaurants a little bit lower, and Candace overall rates restaurants a little bit higher. There's one other pesky thing going on here is we have this warning here about null variables. So if I click on that, Tableau gives me this option to filter my data to remove the nulls. And that's what I'm going to do. So now that we have our bar chart, we're going to do just a little bit of cleanup. I'm going to get rid of this first name here, which I can just right click and hide field label. And I'm going to give this a title, and it's going to be average rating, or average restaurant rating. Okay. I'll click apply and OK, and we have a bar chart. Go ahead and save your project, rename your sheet, and I'm going to call it bar. And we are going to move on for our very last chart, which will be a line chart. So we have our last one here, and we're going to use some really interesting metadata from this sample. So we have these timestamps that tell us when each person answered the survey. And what this will allow us to see is how many people answered the survey on a given day or on a given hour or just generally over time. So this is our time series data. So I'm going to start by pulling my timestamp over here to the columns, and then I'm going to put the count of the restaurants over here on the rows. And what do we get? Well, we get something kind of interesting. It looks like we only have one data point here, and it's for 2019. What's happening? Well, Tableau has very helpfully transformed our data into years, but that's not at all what we want. So, I accidentally clicked that, sorry. If we click on this drop-down menu, we can change the day type. We can use quarters, months, week numbers, or days. And what we see is that there is a peak over here on May 19th. There's one down here, and 2 were added on May 11th. We also have this warning about the nulls. We are again going to remove them. Excellent. So let's take a minute here to talk about Tableau and the relationship between columns and rows and the X and Y axis. I find this to be endlessly confusing, and I hope that you don't have the same confusion. So you'll notice that we brought this time pill over here to columns, but columns are the X-axis. What I think that Tableau is trying to say to us is columns are the up and down things, whereas rows are the Y-axis and therefore the horizontal things. I'm not really sure how to give you a way to remember that, totally honestly, other than to remember that in the world of Tableau, columns is what you want on the X-axis, and rows is what you want on the Y-axis. All right, so we're going to move on and do a little bit of cleanup of this line chart here, and this is going to be responses by day. I'll apply that to my title. Distinct count of restaurants is not exactly the most eloquent title here. So I'm just going to say number of responses because it actually has nothing to do with the restaurants. And even better, I'll just say response volume. And if I close that, I believe it updates automatically. And then I'm going to edit this one as well. And I'm just going to call it May. I'll just call it days 2019. Let's see, can we get rid of the bracket? I don't believe so. Okay. Yes, and we'll close that. Excellent. All right. So the very last step that you should be getting really good at by now is save your project, rename your sheet, call it line, and then we are ready to move on to put it all together and make our very first dashboard. Ultimately, these 5 visualizations are going to form the backbone of everything that we're going to do in this class. Pretty much every visualization is some sort of spin on these core 5. There's obviously going to be different ones, and obviously we're going to work on a lot more of the theory and visualizing bigger data sets. But this core will get you pretty far. All right. I hope that you enjoyed the video, and I look forward to seeing you in the dashboards video. All right, take care. Bye-bye.